Section 4 of the pre-U syllabus, Energy Concepts. Statement J is derive, recall and use E equals half kx squared. The E in this equation is the energy stored in a stretched spring or a compressed spring. K is the spring constant, usually given in units of newtons per meter, and x the extension of the spring. It's probably worth quickly reminding ourselves, when you take a spring, it has some length even when there is no force acting on it. I'll label that L. If I apply a force to my spring, we expect to see its length increase. To some new increased length that I'll call L prime. The extension is defined as the extended length minus the original unextended length. For the equation E equals half kx squared, we should be thinking about our standard physics equation for mechanical work done. That is, work is force times distance, but this equation assumes a constant force acting through some distance. If I was to plot the force of someone pushing a car that had broken down through some distance x, this equation is effectively telling us that the area captured under this graph is the same as the amount of work that is done in pushing the car through this distance. Springs don't work like that. In a spring, the force required to extend it keeps changing. When we plot a graph of F against X, we find that we produce a straight line that goes through the origin. So when thinking about the area captured by this graph, it's a triangle. It's not a rectangle. And therefore, when we come to write it down, we say that the energy stored, or the work done on the spring, is a half Fx. Substituting in our standard formula for springs, that the force is the spring constant times the extension, we can rewrite this equation as E equals half kx times x, or simplified, E equals half kx squared.